Hello everyone, this is Partha Sarathi and the topic is assembly line balancing. Okay, right. What is assembly line balancing? A simple brief about it is, in any production or in any operating activity, the activities are arranged in a sequence of order in order to reduce the time and to optimum utilization of workers, machines and workstations. We call it as assembly line. See, for example, I'll tell you a simple example. In an organization, if you want to produce a product, it involves various activities, various sequence of activities. Let us see a brief about it. See here, there is a project. Here there is an activity. Activity is nothing but the work which we have to do. The work which we have to do, you call it as activity. There is activity A. Okay, right. This activity A is preceded. That is the activity before this activity we call it as preceder activity. Okay, right. The activity is nothing but the work which we have to do, and preceder is nothing but the activity which is before this activity. As activity is as the activity A is the first activity, there is no preceder. And T time refers to time. See, for completing of activity A, it requires 8 days. 8 days. Okay, from A it moves to B. Okay, that is activity B. Before the activity B, there is activity called A. Okay, the time completion for completion of this B activity is 12 days. Okay, and there is activity C. The activity C is preceder. Preceder is nothing but before this activity C we have B activity. It takes 4 hours time. 4 hours, 4 days of time. Then D, before D there is B activity. Okay, and E, there is preceded activity is C and D. The time taken is 8 days. That is what we are doing is, what is the activity, what is the work we are mentioning here, what is the preceder work, that is the work before this activity we are writing here, and then what is the time taken here. Okay, let us see how we have written. The network can be drawn by using two conventions: activity, that is activity on arc or activity on node. Okay, let us see what is this activity on arc. Let us see the diagram. This is called as activity on arc. Activity on arc. See, A is the activity. A is the activity. That is first activity. And in brackets we have 8. 8 is, what is that 8? 8 is nothing but the number of days, the time period we write here. A is the activity and the number of days we write, the time period right in the brackets. This arrow mark we call it as an arc. See here, it shows that AOA diagram denotes that A, B, C, D, etc. are mentioned on the arc. Okay, figures in brackets are adjusted to the activity. A, B, C, D, E, F, G, H. These are all the activities. These are all the works. And in brackets, we'll write the time period: 8 days, 12 days, 4 days, 2 days, like this. Okay, then we'll find out the relationship, that is which is the preceder one. Okay, see here in the diagram we'll find the preceder. A, first activity is done by A in 8 days, and this act, after completion of this activity will go for B activity. It completes in 12 days. Then it goes for the third activity. The third activity is C and D. Okay, and this activity is followed by E and F. See, this dotted lines we call it as dummy activity. We call it as dummy activity. Dummy activity. Okay, and then these are the preceding. This is the starting one and this is the ending one. These lines we call as arcs. Okay, let us see for the other method in simple way, that is nodes. Arc, that is activity on nodes. That is starting activity A activity. After A activity will complete in 8 days. After A activity it is followed by B activity. After B activity is followed by C and D activities. D and D activity is related to E activity in the dummy form, and this D is followed by preceded of E and F, and then G, H and end of the activity. That is in very simple we will write the activities, and the preceded activity, that is the activity before this activity, and then time period in the tabular form, and we will write in a network form, okay. See here, this diagram, we will analyze the diagram. Path 1, A, B, C, E, G, end of the path. The first one, A, B, C, E, G. A, B, C, E, G. Second one, A, B, D, F, H, end one. The third one is A, B, D, E, G, H. That is, a particular diagram has different paths and different time periods. What we will do now? We will add up all the time periods. A requires 9 hours, B requires 12 hours, 4 hours, 8 hours, 3 hours. That is, we will add up the first path time periods, second path time periods, third path time periods, and we will see the number of days. See, out of these, which path is having less number of time period? It is having 26 days. That is path 2, that is A, B, D, F, H is having less time period. Okay, let us see here. This path A, B, D, E, G is having less time period. Okay, right. Now we'll see the simple about the assembly line balancing. Up to now we have gone for what is this networking. Now let us see what is this assembly line balancing. Let us see, assembly line balancing is the production strategy that sets intended rate of production to produce a particular product within a given time frame. We can simply say that assembly line balancing is a process which is designed to take a particular activity. We design the particular activity, see here, designed a particular activity, and will distribute among the workers. For A activity, how many number of workers, how many number of machineries, and how many number of workstations. Okay, and we will relate these workers, machines, and workstations, and we will try to reduce the time period without any delay. That is, there is no wastage of time period. We will check there is no wastage of time period. Okay, let us see the next. The very simple, assembly line balancing can also defined as assigning proper number of works and machines. See, for example, there is activity A, that is welding. Consider welding. Welding is an activity. It requires 5 hours of time, 3 machineries, 10 labor. That is our task. That is our activity. That is, we have 3 labor, 5 hours of time, and 10 labor. Okay, what we are doing that? We are arranging number of workers, number of machines for each operation, that is for each activity on assembly line. Assembly line is simple, nothing but there are different activities. These activities are grouping together like welding, painting, molding, shaping, turning, right? These are all in a sequence of activities. Okay, right, so as to meet with the required production rate with the minimum or zero idle time. What is idle time? Idle time is nothing but the time gap between activity A and activity B. Right? See, an activity A is completed in 5 days and activity B is completed in 6 days. Okay, a particular product has to move from A to B. There should be no time waste. Ideal means waste of time. There should be minimum time waste, or ideal zero idle time. That is no wastage of timing. See, coming to what are the balanced line and its effects. That is, we can simply say that what are the advantages of balanced line. That is, promotes one piece workflow. That is, there is a continuous flow of work. Okay, avoids excessive workload in some stages. That is, it says that because of this, the workload excess, that is work burden, more work is reduced. As the work is done in a sequence of activities, the workload is reduce. See here, because of this balance line activity, the work burden is reduced, and it minimizes, because of assembly line, it minimizes the wastage, that is over processing, over inventory, waiting time, rework, that is a particular work it doing again and again, and transportation, movement of motion, that is movement of material from one place to other. These 6 types of wastages are reduced. What are the 6 types of wastages? Over processing is a wastage, inventory is a inventory wastage, waiting wastage, rework, transportation, motion. These wastages can be reduced. Okay, and it reduces variations. In case of assembly line production, it reduces the variation. That is that is the there is difference in the quality of the product can be reduced, right? And also it increases the efficiency. Efficiency is nothing but how well we can produce the products, that is our efficiency. Our efficiency can also be increased, and it increases the it minimizes the idle time. What is idle time? That is, there is no wastage of time from one activity to other activity. That time can be reduced. Okay, right. Next, then coming to unbalanced. What happens if there is no assembly lines balancing? There is high work, that is reverse of it. High workload in some stage, that is overburden, overwork. Maximizes of wastages. See, advantages is minimizes of wastages, and in case of unbalanced one, maximizes of wastage, that is over processing, inventory, waiting, rework, transportation is reduced. And high variation in output, that is the quality, quantity, there is a high variation. And restrict to one piece flow, that is we can produce only one type of product. And maximize the idle time, that is if there is no balance of assembly line, then the idle time is more, there is more wastage of time, that workers time, machines will become idle, production will become idle, and the efficiency is poor. That is, it is the reverse of balance line effect and the unbalanced effect. Okay, right. Then how can assembly line balance help the organization? It increases the efficiency of the organization, it increases the productivity of the organization, the potential increase in profits and decrease in cost. That is, profits are increased, costs are decreased, productivity is increased, and as well as efficiency is also increased. Okay, right. Let us see what are the steps involved in assembly line balancing. These are very simple steps. If you go for a problem, then it can be easily understand. Let us go for the theoretical one. List the sequential relationship among the tasks and then draw a preceding diagram. Right, we have gone for a preceding diagram. This we call it as preceding diagram. Activity, preceding activity. Okay, activity, this is the B activity, C is the preceding activity. Okay, E is the preceding activity of C and D. In this way, we have to construct a preceding diagram. Okay, calculate the required station cycle time. That is, what is the time period for a single path and what is the time period for the total paths we will calculate. Okay, right. Next, and then calculate the theoretical minimum number of workstations. That is, how many number of workstations are required and what is the minimum number of workstations required. Choose a primary rule that will determine how tasks are assigned to the workstation. That is, how will we assign the task to a particular workstation, and then begin with the first workstation, assign each task at one at a time until the sum of the task time will equal to the workstation cycle time, or until no other task will take task can be assigned due to the sequence of time restrictions, and repeat these steps and evaluate the efficiency of the line balance, rebalance stiffness. That is, right. See, all these 8 steps we can simply understand this problem. Let us see. A is the activity and the time period. B is the activity, time period. C is the activity, time period. Now we are required to calculate what is the actual time period and what is the efficient balance, assembly line balance. Okay, right. See, this is our data. Given is the assembly balance line showing the table activities that needed to be completed and produce a product. The actual time required to produce each of the activity is given here. The assembly line has 5 workstations stated on the line as follow, where backtracking is not allowed. Backtracking is nothing but from E to A, H to D, that is from reverse. That is, a work is moved from A to B and again it should not go from B to A. That is called as backtracking. Okay, right. Let us see. See here we have 5 different workstations. Workstation 1, 2, 3, 4, 5. The product is in, that is the raw material is in the workstation. The raw material get into workstation 1. It moves to workstation 2, 3, 4, 5. And the activities at workstation 1 are AB, at workstation 2 is CE, DH, that is FII, FIL, and at workstation G, JKM. Okay, so there are number of workstations is 5. Okay, well, total processing time is 30 plus 50 plus 40, that is the time taken. See here they have given the time taken, that is 30 plus 50 plus 50, that is the time. We will add up all the time so that we will get the total time taken to complete the process. That is from workstation 1 to workstation 5, that is from raw material to finished product, it will take 350 seconds. Okay, right. Next, and then what is the cycle time? That is, what is the maximum cycle time is for workstation A, B, 80. That is, what we will do here is A and B, that is 5. A is 30, B is 50, 30 plus 50, 80. And at workstation 2, that is at CE, it is of, at workstation 2, then at workstation 2 there are 2 activities are occurring, that is C activity and activity E, that is C and E. The time taken is 40 plus 20, which gives us 60. In the same way we will calculate for DH, FIL, GJ, KM also. So that we will get all the maximum cycle time. That is at AB it takes 80 seconds. At workstation 2 it takes 60 seconds. Workstation 3 it takes 70 seconds. So what is the maximum work cycle time is 80 seconds. That is at workstation 1. Okay, right. Now let's go for the next one. That is balance delay. What is the balance delay is nothing but that it indicates the idle time on the assembly line. That is, there is no work. That is, the machines on men and everything is just simply idle. There is without work, they are simply idle. That we call as idle time. Here the idle time is, balance idle time is N, that is number of workstation, CL, that is maximum cycle time. That is maximum cycle time is here 80, maximum cycle time is 80 CL minus TP, that is processing, total processing, that is 350. How we get this 350? We will add up all the timing, that so that we get 350 pi divided by N refers to number of cycles, that is 5 by 5 workstation into cycle time maximum of 80 by 100, so that the idle time is 12.5% out of the total time. Out of the total time of 350 seconds, 12.5% of time is idle without any work. Okay, then production rate. What is the production rate? For production rate is assuming that production will happen 24 hours in 3 shifts. That is, for each shift 8 hours. The employees are working for 8 hours. 8 into 3, that is 24 hours. The work is happening. So what is the production rate is? Available time by cycle time. What is the available time? 24 hours, 60 minutes, right? 60 seconds by cycle time of 80. So that we get 1080 units per day. Per day we are getting 1000 units, 1080 units. Okay, right. Next we go for, if we rearrange this assembly line so that we will reduce the idle time and we can increase the number of products. See here, number of workstations is 5, total processing unit is total time period is 350, TP by N, that is processing total processing time by number of workstations is equal to 70 seconds. So what we will do, see, after rearrangement, what happen at the cycle time is distributed equally at all the workstations, so that cycle time is reduced. So what happened is, here see here, the cycle time is 70 seconds, balance delay is 0, that is nil, there is no wastage of time. Coming to production rate, availability time by cycle time. Available time is 24 hours, that is we are working with 24 hours, 3 shifts, 8 hours per day, that is 24 hours into 60 minutes 60 seconds by 70 of cycle unit, that cycle time. So that we production rate is 1234 units. So if the assembly line can produce 1234 units per day, after rearranging the assembly line, so the production is increased by 151 units, so that 14% of production is increased after the rearrangement. So finally we conclude that it is clearly understand that after reallocation of activities, tasks, individual workstations in assembly line, we can increase the production by 14%. In manufacturing industry, it is always necessary to rearrange the activities based on the workstation requirement, so that the processing time is reduced and we can produce more number of products, which leads to zero or very minimum ideal time. Okay, right, this is a brief about our assembly line. If you have any doubts, you can contact me. Thank you.